Hi, welcome to Quick Review with Sergio. So this time we will have a tutorial using a free application known to be as JASP or JASP or Jeffrey's Amazing Statistics Program. So in this video, we will be studying, analyzing using linear regression. So we will consider first the data. So let's open. So the data we have height as the predictor and jump distance as the outcome. So we will see the influence of height to jump performance or the distance. So before we will perform linear regression, we have to review the assumptions. So first assumption, keyword dependent variable should be continuous. So we can check the JAS. Similar to assumption number two, the independent variable should also be continuous. So we will check the data. So basically, both IV or predictor, the height, and DV or outcome are continuous, meaning the first two assumptions are satisfied. So we will see with the third assumption, there needs to be a linear relationship between the two variables. So we can check this one using a scatter plot. So it should be linear. So we can check this using correlation. So let's see. Correlation. So scatter plot. So there needs to be a linear relationship. So we will see. Okay, we will see with the graph. So as you can see, okay, it follows linear form or linear relationship is evident. That also that the third assumption is met. So let's proceed with the fourth assumption. There should be no significant outlier. So from the scatter plot, we can see it. So going back to the scatter plot, okay, as we can see, there is no significant outlier or extreme value. So we can proceed. Okay, next. Number five, you should have independence of observation. So we need the Durbin-Watson result. So usually a rule of thumb is a range of 1.5 to 2.5. So let's perform regression, linear. Okay, dependent variables, jump, height. We have, okay, covariates. We will see with the statistics, Durbin-Watson. So basically, we have the statistic. Okay, this M sub 1. Okay, it's 2 point something, meaning we were able to satisfy also the this, meaning that this assumption is met, meaning relatively normal. We were able to avoid the autocorrelation. And as you can see with the P, okay, it's greater than 5%, meaning, okay, similar to normality, okay, we met, okay, we satisfy the assumption. So let's proceed with the sixth assumption. So your data needs to show homoscedasticity. So we will see if the variances along the line of best fit remain similar as you move along the line. So we can check one using a scatter plot, but we have to consider the residuals versus predicted values. So we will see. So we can check that in the plots. So residuals versus predicted. Okay, we will see. So yes, as you can see, homoscedasticity is evident. So there's also an illustration here. So this is very similar to this graph. Okay, meaning We were able to satisfy this assumption. Okay, next is number 7. You need to check the residuals, the errors of the regression line are approximately normally distributed. So basically, this is the last assumption, and this is very important. So we can consider the standardized, and we will see if this is met. So exports, click here. Let's name residuals and then predictions, and then standardize. So we will see we have here. So from here we will correlate this. Okay, we have here now correlation. So this must be normal. We will see. Let's use Shapiro-Wilk test. Assumption check pairwise. Okay, since it's greater than 5%, meaning, okay, we were able to satisfy this last assumption and the data is normal. So basically, this is the last assumption. And since all of the assumptions were met, we can proceed with the analysis. So this is a very important consideration, okay, for us to really assure that we are dealing with the appropriate statistical tool. So we'll proceed with the regression results. So we are expecting this table influence of high to long jump performance. So from the result, we will see if it's it it's actually here. So the R is 0.706, 0.706 correct. R squared 0.499. Let's see, 0.499. So basically, R squared is coefficient of determination, and the R is the Pearson's correlation, the simple one. And let's see, the height is a significant predictor. Yes, 0.005. Let's see, 0.005. That's correct. And F is 11.95. 11.95 rounded off. And this is correct. And for the specific, you will see height. Okay, that's correct. 0.005. We will check the regression equation. The height is 1.039. 1.039, that's correct. The constant is 0.667. 0.667. So we can form now the regression equation. Okay. And we can consider the unstandardized. We will be using the B for our regression equation, but we have to reflect this one, including the t value and then the p value with the remarks. Okay, so from the result, we can really see that height significantly influence long jump performance. So again, so this is a quick video tutorial using JASP. Thank you. Don't forget to subscribe.